The universe, a boundless expanse so vast that words fail to truly capture its enormity. From the tiniest particles to galaxies so far away their light takes millions of years to reach us, everything is connected by an intricate web of cosmic forces. And yet, what do we really know? In this infinite ocean of stars, planets, and unknowns, humanity stands on the precipice of discovery. Join us on an unforgettable journey. We'll explore the wonders of space, its birth, its power, its mysteries, and uncover the stories that have shaped our understanding of the cosmos. Are you ready to explore the universe, one story at a time? Space, an endless expanse filled with more mysteries than we could ever possibly comprehend. Each corner of the cosmos is a testimony to cosmic wonders and chaotic beauty. But what if we told you that space, as immense as it is, has its origins in something far simpler than we imagine? The story of space begins not with the vast galaxies we admire from afar, but in a much humbler setting. Our solar system, a region that seems so familiar to us, has a history that stretches back billions of years. The birth of our solar system. Our solar system was born over 4.5 billion years ago within a colossal cloud of gas and dust. This cloud, primarily composed of hydrogen and helium, was not just the building block for our sun, but for the entire solar system. It was a stellar nursery where new stars are born. And as it collapsed under its own gravity, the story of our solar system began. As the gas cloud collapsed, it spun faster and faster, a phenomenon known as the conservation of angular momentum. This spinning cloud began to flatten into a disk, and at the center, the cloud became dense enough to ignite nuclear fusion, giving birth to the Sunday. The sun, our life-giving star, became the core of the solar system. But surrounding it was the rest of the material, the leftover dust and gas that would go on to form planets, moons, and other celestial bodies. The process of forming planets began with tiny particles colliding and sticking together. These collisions led to the formation of planetesimals, small building blocks of planets. Over time, these planetesimals grew larger, and in some regions of the solar system, they eventually formed protoplanets. In the inner regions of this disk, where temperatures were higher, only rocky and metallic materials could condense. This is why the inner planets, Mercury, Venus, Earth, and Mars, are rocky worlds, while the outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants, able to accumulate vast amounts of hydrogen and helium. Planetary profiles. Now, let's take a closer look at the planets that make up our solar system, starting with the smallest and working our way outward. Mercury, the closest planet to the Sun, is a small, rocky world with extreme temperature fluctuations. During the day, temperatures can soar to nearly 800 degrees Fahrenheit, while at night, they plummet to a frigid -330 degrees Fahrenheit. Mercury has no atmosphere to trap heat, and its surface is heavily cratered, much like our moon. It's a world of extremes, where the sun's blistering heat is only balanced by the coldness of the night. Venus, Earth's sister planet, is often called the hottest planet in our solar system. With surface temperatures reaching a scorching 900 degrees Fahrenheit, Venus is a toxic and inhospitable world. Its thick atmosphere is composed mainly of carbon dioxide, with clouds of sulfuric acid, creating a runaway greenhouse effect that traps heat. Venus's dense atmosphere makes it nearly impossible to observe the surface directly, but recent missions have revealed volcanic plains and evidence of ancient, long-extinct volcanic activity. Earth, our home, is unique in many ways. It is the only known planet with liquid water, a critical component for life as we know it. Earth's atmosphere, rich in nitrogen and oxygen, shields the planet from harmful radiation, while the magnetic field protects it from the solar wind. Our planet's stable orbit, along with the moon's gravitational pull, has created the perfect environment for life to flourish. Mars, the red planet, is another intriguing world. Although it is now a cold, barren desert, Mars once had flowing water. Evidence of ancient riverbeds and polar ice caps suggests that liquid water once covered the surface. Mars is home to Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs the Grand Canyon. These geological features hint at a turbulent past, where volcanic activity and shifting tectonic forces shaped its landscape. Jupiter, the gas giant, is the largest planet in our solar system. Composed mainly of hydrogen and helium, Jupiter has a unique feature that sets it apart from other planets, the Great Red Spot, a massive storm that has been raging for at least 350 years. Jupiter's immense gravitational pull has shaped its surroundings, capturing numerous moons, including Europa, which scientists believe may harbor a subsurface ocean capable of supporting life. Saturn, another gas giant, is most famous for its stunning rings, made up of ice and rock particles. These rings extend over 175,000 miles from the planet, though they are only a few hundred feet thick. Saturn's rings are not only beautiful, but also provide valuable insights into the planet's history. Saturn has more than 60 moons, including Titan, which has an atmosphere similar to Earth's early atmosphere and is considered one of the most promising places in our solar system to search for signs of life. Uranus and Neptune, the ice giants, are the farthest planets from the Sun. Uranus is unique for its extreme axial tilt, about 98 degrees, causing it to rotate on its side. This extreme tilt leads to unusual seasonal patterns. Neptune, the more distant of the two, has some of the fastest winds in the solar system, with speeds exceeding 1,200 miles per hour. Both planets are primarily composed of hydrogen, helium, and methane, giving them their distinctive blue-green color. The Sun, our lifeline. The Sun is the heart of our solar system, providing the light and heat that sustain life on Earth. It is a medium-sized star, classified as a G-type main sequence star, but its influence is anything but small. The Sun's core, where nuclear fusion occurs, is the engine that powers not only the Sun, but the entire solar system. Nuclear fusion, the process by which hydrogen atoms fuse to form helium, releases an enormous amount of energy in the form of light and heat. This energy takes thousands to millions of years to travel from the core to the surface, but once it reaches the surface, it travels through space at the speed of light, providing the energy necessary to sustain life on Earth. The Sun's gravitational pull is also what keeps our planets in their orbits. Without the Sun's massive gravity, the planets would drift off into the cold abyss of space. The Sun's influence is felt throughout the solar system, affecting everything from the orbits of the planets to the behavior of comets and asteroids. The Moon and other celestial bodies. The Moon, Earth's only natural satellite, has been a constant companion in our journey through space. Its phases, from the new moon to the full moon, have guided humans for millennia. The Moon's gravitational pull causes the tides on Earth, a constant reminder of the powerful forces at play in the universe. Beyond the planets, there are countless other celestial bodies that make our solar system unique. Asteroids, comets, and the moons of other planets add to the complexity and wonder of the cosmos. The asteroid belt, located between Mars and Jupiter, is a region of space filled with rocky bodies that never formed into a planet. Some of these asteroids, like Ceres, the largest object in the belt, are classified as dwarf planets. Comets, often described as dirty snowballs, are icy bodies that travel through space, leaving behind trails of gas and dust as they approach the Sun. Their spectacular tails are one of the most beautiful phenomena in the night sky, and they provide scientists with clues about the early solar system. This journey through our solar system is just the beginning. As we continue our exploration of space, we will venture further out into the Milky Way galaxy and beyond, uncovering the mysteries of the universe. From the birth of stars to the discovery of exoplanets, the universe is full of secrets waiting to be revealed. The stars are just the beginning. The wonders of stars and stellar evolution. Stars, the magnificent beacons of light scattered across the universe, come in many forms. From the smallest red dwarfs to the massive blue supergiants, each star is a unique product of cosmic processes that stretch over billions of years. Stars are not only the source of light and heat in the universe, but they are also the factories where the elements that make up everything we know, including ourselves, are forged. The life cycle of stars. Stars are born in vast, cold clouds of gas and dust, called molecular clouds, often referred to as stellar nurseries. These clouds, mostly composed of hydrogen, are the raw material for the formation of new stars. Over time, these clouds experience gravitational collapse, causing the gas and dust to come together and form dense clumps. As these clumps continue to collapse, their cores heat up, eventually reaching temperatures high enough to ignite nuclear fusion. This is the moment a star is born. The star enters what is known as the main sequence phase, where it spends most of its life. During this time, the star is primarily converting hydrogen into helium in its core, releasing vast amounts of energy in the form of light and heat. Our Sun, for example, has been in this phase for about 4.6 billion years and will remain in the main sequence for another 5 billion years. As stars begin to exhaust their hydrogen fuel, they start to evolve. The process of evolution depends on the star's mass, and this is where the story of a star's life gets particularly interesting. Stars like our Sun will expand into red giants, shedding their outer layers and leaving behind a dense core known as a white dwarf. Over billions of years, this white dwarf will gradually cool and fade, its light slowly dimming until it becomes a faint remnant of its former glory. However, massive stars follow a much more dramatic path. These stars, which have at least 8 times the mass of our Sun, will go through more violent stages as they burn heavier and heavier elements in their cores. Once these stars have exhausted their fuel, they will undergo a supernova explosion, a cataclysmic event that releases more energy than our Sun will ever produce in its entire lifetime. This explosion creates heavier elements such as iron, which are then scattered throughout the cosmos, enriching the universe with the building blocks for planets and life. What remains after the explosion depends on the mass of the original star. Stars with masses between 8 and 25 times that of the Sun collapse into neutron stars, while those with masses greater than 25 times the Sun's will collapse into black holes. Neutron stars and black holes. Neutron stars are incredibly dense remnants of stars that have exploded in supernovae. These stars are so dense that a single teaspoon of material from a neutron star would weigh about 1 billion tons. Neutron stars are often marked by their pulsar nature, emitting beams of radiation as they rapidly rotate, sweeping these beams across space like a cosmic lighthouse. The strongest magnetic fields known in the universe are found in neutron stars, and their gravitational fields are so strong that they warp space-time itself. Black holes, the most enigmatic objects in the universe, form when a massive star collapses under its own gravity. The core of the star becomes so dense that it creates a region in space where gravity is so strong that not even light can escape. This boundary is known as the event horizon. Inside the event horizon, everything is drawn toward the singularity, an infinitely small point where matter is compressed to an infinite density. Black holes are invisible, but their presence can be inferred by their effects on nearby objects, such as stars or gas clouds that spiral into them, creating powerful jets of radiation that we can detect across vast distances. Exoplanets, worlds beyond our solar system. As we venture further into space, we find that our solar system is not the only one of its kind. In the vastness of the Milky Way galaxy, there are billions of stars, and most of them likely have planets orbiting them. These planets are known as exoplanets, and discovering them has become one of the most exciting frontiers in modern astronomy. The first exoplanets were discovered in the 1992, and since then, thousands have been identified. The methods used to discover these distant worlds include the transit method, where astronomers measure the slight dimming of a star's light as a planet passes in front of it, and the radial velocity method, where scientists measure the slight wobble in a star's motion caused by the gravitational pull of an orbiting planet. More recently, direct imaging of exoplanets has become possible, allowing astronomers to capture pictures of planets around distant stars. Exoplanets come in all shapes and sizes, and many of them are unlike anything we see in our own solar system. Some are super-Earths, planets with masses larger than Earth's, but smaller than Neptune's. Others are gas giants, similar to Jupiter, but orbiting much closer to their stars. And then there are the potentially habitable exoplanets, planets located in the so-called habitable zone of their star, where conditions might be just right for liquid water to exist. These planets are prime targets in the search for extraterrestrial life, and studying them could offer us the greatest hope of finding life beyond Earth. The Milky Way, our cosmic home. The Milky Way galaxy, the very home of our solar system, is just one of billions of galaxies scattered throughout the universe. It is a vast, spiraling collection of stars, gas, dust, and dark matter, held together by gravity. The Milky Way is about 100,000 light-years in diameter, and it is made up of several distinct components, including the galactic bulge, the spiral arms, and the halo. At the center of the galaxy lies a supermassive black hole, known as Sagittarius A*. This black hole has a mass about 4 million times that of our Sun and exerts a powerful gravitational pull on the stars and gas in the galactic center. Surrounding this black hole is the galactic bulge, a densely packed region of stars, many of which are old and red. The spiral arms of the Milky Way are regions of active star formation filled with young, hot stars and nebulae. Our solar system resides in the Orion Arm, a minor spiral arm located between the larger Perseus and Sagittarius arms. The Milky Way is not static, it is constantly evolving. It has been shaped by countless interactions with other galaxies, some of which have collided with it in the past. In fact, the Milky Way is on a collision course with the Andromeda Galaxy, our nearest large neighbor. In about 4 billion years, the two galaxies will collide and merge, creating a new, larger galaxy. This event will be a spectacular sight, but it will not pose a threat to Earth, as the stars within each galaxy are so far apart that they will not collide. Dark matter and dark energy, the invisible forces. Despite the fact that they make up about 85% of the universe's mass and 70% of its total energy, dark matter and dark energy remain some of the most mysterious and elusive components of the cosmos. Dark matter is a form of matter that does not emit, absorb, or reflect light, making it invisible to our most powerful telescopes. Its presence is inferred from its gravitational effects on visible matter, such as galaxies. Scientists believe that dark matter is responsible for holding galaxies together, as without it, the gravitational pull of galaxies would be too weak to keep their stars and gas from flying apart. Dark matter does not interact with light or other forms of electromagnetic radiation, making it incredibly difficult to study. Dark energy, on the other hand, is believed to be responsible for the accelerated expansion of the universe. It acts as a force that opposes the pull of gravity, pushing galaxies apart. Dark energy is thought to make up about 70% of the universe's total energy content, but we still don't fully understand what it is or how it works. Together, dark matter and dark energy play a crucial role in the structure and evolution of the universe, but they remain some of the greatest mysteries in astrophysics. Galaxies, the building blocks of the universe. Galaxies are the fundamental units of the universe, vast collections of stars, gas, dust, and dark matter bound together by gravity. They come in a variety of shapes and sizes, each with its own unique characteristics. Some galaxies are sprawling and spiral, like our Milky Way, while others are elliptical or irregular in shape. At the core of each galaxy lies a supermassive black hole, and around them, stars form in massive clusters known as stellar nurseries. These stellar nurseries are regions of active star formation, where new stars are born from clouds of gas and dust. As stars form, they interact with the material around them, affecting their surroundings and giving rise to new celestial phenomena. Types of galaxies. There are three main types of galaxies: spiral, elliptical, and irregular. Spiral galaxies, like the Milky Way, have a distinctive shape, with arms of stars, gas, and dust that spiral outward from a dense central bulge. The Milky Way, for example, is a barred spiral galaxy, meaning it has a central bar-shaped structure of stars. Spiral galaxies are often rich in gas and dust, which provides the raw material for ongoing star formation. The spiral arms are where we find the youngest, hottest stars, while the central bulge is made up of older stars. Elliptical galaxies, on the other hand, have a more rounded or oval shape. They lack the distinct spiral arms and are often populated by older, red stars. These galaxies are thought to have formed through the merger of smaller galaxies, leading to their more uniform structure. Unlike spiral galaxies, elliptical galaxies tend to have little gas or dust, which means they are no longer forming new stars. Their older stars are often densely packed together, giving them a smooth, uniform appearance. Irregular galaxies do not have a defined shape and appear chaotic in structure. They are often smaller than spiral and elliptical galaxies and can be the result of gravitational interactions with other galaxies. Despite their disorganized appearance, irregular galaxies can still be home to regions of active star formation, and some may eventually evolve into spiral or elliptical galaxies through mergers or other processes. Each type of galaxy reveals a different chapter in the universe's history, from the chaotic birth of stars to the peaceful aging of old, dying systems. These galaxies, along with their stars, serve as the building blocks for the larger structure of the cosmos. The fate of our universe. The fate of the universe is a subject of great debate among cosmologists and astrophysicists. What will happen to the universe in the distant future? Will it continue to expand forever, or will it one day collapse in on itself? Several theories attempt to answer these questions, each presenting a different view of the universe's eventual destiny. The Big Freeze. One of the most widely accepted theories is the Big Freeze, also known as heat death. This theory suggests that as the universe continues to expand, galaxies, stars, and other celestial bodies will drift further apart. Over time, stars will burn out, and the universe will become increasingly cold and dark. Eventually, all matter will be spread so thinly that it will no longer be possible for new stars to form. The universe will slowly cool, becoming an inhospitable place, devoid of life and light. This would be the end of all activity in the cosmos. The Big Crunch. In contrast to the Big Freeze, the Big Crunch theory suggests that the universe will eventually stop expanding and begin contracting. This could happen if the gravitational pull of all the matter in the universe is strong enough to reverse the expansion. As the universe contracts, galaxies, stars, and planets would be pulled closer together, ultimately collapsing into a singularity, a point of infinite density. The Big Crunch would mark the end of everything, as the universe collapses in on itself, potentially leading to the birth of a new universe in a cycle of rebirth. The Big Rip, a more recent theory, known as the Big Rip, suggests that the expansion of the universe could continue to accelerate, driven by dark energy. If this acceleration continues, it could eventually tear apart galaxies, stars, planets, and even atoms themselves. The force of expansion would become so strong that it would overcome the galaxies, gravitational forces that hold everything together, ripping the universe apart at its seams. The Big Rip presents a terrifying but fascinating end, one in which the very fabric of space itself is destroyed. Exploring the cosmic horizon, the quest for knowledge. Despite the potential end scenarios, the pursuit of knowledge remains a driving force in humanity's exploration of space. For centuries, we have gazed up at the night sky, marveling at the stars and wondering what lies beyond. With the advent of advanced telescopes, space missions, and artificial intelligence, we are now able to peer deeper into the universe than ever before. Space telescopes and observatories. Space telescopes, like the Hubble Space Telescope, have revolutionized our understanding of the universe. Orbiting far above Earth's atmosphere, Hubble has provided breathtaking images of distant galaxies, nebulae, and other cosmic phenomena. Its observations have helped us understand the age of the universe, the life cycle of stars, and the nature of black holes. The James Webb Space Telescope, launched in 2021, is the next leap forward in space observation. With its advanced infrared capabilities, it will allow scientists to see farther into space and time than ever before. Webb's mission is to study the formation of the first galaxies, the birth of stars, and the potential for life on distant planets. Its groundbreaking observations will undoubtedly shape the future of space exploration. Future space missions, the road ahead. As we continue to explore the universe, new missions will take humanity farther than ever before. NASA's Artemis program, for example, aims to return astronauts to the moon by 2024 and establish a sustainable human presence on the lunar surface. This program will serve as a stepping stone for future missions to Mars, with the goal of sending humans to the Red Planet in the coming decades. Private companies like SpaceX are also pushing the boundaries of space exploration. SpaceX's Starship rocket, designed for long-term missions to Mars and beyond, represents a bold step forward in human spaceflight. With reusable rockets and ambitious plans to colonize other planets, SpaceX is paving the way for a new era of space exploration. The exploration of Mars is one of the most exciting frontiers in space. With its similar characteristics to Earth, scientists believe that Mars could one day support human life. Missions like NASA's Perseverance rover are currently studying the surface of Mars, searching for signs of past life, and preparing the groundwork for future human missions. The search for extraterrestrial life. One of the most profound questions humanity has ever asked is, are we alone in the universe? The search for extraterrestrial life is one of the primary goals of modern space exploration, and with the discovery of thousands of exoplanets, we are closer than ever to answering this question. Exoplanets located in the habitable zone of their stars where conditions may be right for liquid water are prime targets for future exploration. Telescopes like the James Webb Space Telescope and space missions like NASA's Kepler mission are helping to identify potentially habitable worlds that could harbor life. The universe is a vast, mysterious place, filled with endless possibilities and countless questions. As we continue to explore the cosmos, each discovery brings us one step closer to understanding our place in the universe. And though the universe may be infinite, it is our curiosity, our thirst for knowledge, that will continue to drive us to explore the stars. Exploring the final frontier, the mysteries of space. The vastness of space is both humbling and awe-inspiring. As we move further from our solar system, we enter the Doofest realm of distant stars, galaxies, and celestial phenomena that challenge our understanding of physics and the very nature of reality itself. It is here, beyond our own cosmic backyard, that the true mysteries of the universe unfold. The enigmatic black holes, perhaps the most enigmatic and mysterious objects in the universe, are black holes. These regions of space-time are so dense that nothing, not even light, can escape their grasp. But despite their name, black holes are not empty space. They are regions where matter has been compressed into an incredibly small volume, creating an infinitely strong gravitational pull. The formation of a black hole begins when a massive star runs out of fuel and collapses under its own gravity. As the star's core contracts, it creates a singularity, an infinitely small point where matter is concentrated. The boundary surrounding this singularity is called the event horizon. And once anything crosses this boundary, it is pulled irrevocably into the black hole. No information can escape from inside this region, making black holes one of the most difficult phenomena to study. Despite their elusive nature, black holes are not only fascinating objects in themselves, but also play a crucial role in the evolution of galaxies. In fact, the supermassive black holes at the centers of galaxies are thought to govern the formation and dynamics of the stars and other objects around them. The gravitational influence of these behemoths shapes the structure of galaxies, affecting everything from the movement of stars to the formation of new solar systems. The study of black holes also ties into our understanding of the nature of spacetime itself. According to Einstein's theory of general relativity, the presence of a black hole warps spacetime around it, causing time to slow down as you approach the event horizon. This strange warping of space and time has led to some of the most mind-bending concepts in modern physics, including the possibility of time travel, the search for gravitational waves. In recent years, scientists have made an extraordinary breakthrough in the study of black holes and the universe itself. By detecting gravitational waves, the ripples in space-time caused by the acceleration of massive objects like black holes or neutron stars, we are now able to hear the universe in a way that was once thought impossible. These waves were first predicted by Einstein's theory of general relativity, but it wasn't until 2015 that they were directly detected by the LIGO Laser Interferometer Gravitational Wave Observatory. Gravitational waves provide us with a new tool for exploring the cosmos, allowing us to study events that are invisible to traditional telescopes. By capturing the tiny distortions in spacetime caused by the collision of two black holes, scientists have been able to observe some of the most extreme phenomena in the universe, giving us new insights into the nature of gravity, space, and time itself. The birth and death of stars, a never-ending cycle. Stars, the building blocks of galaxies, go through life cycles of creation, evolution, and death. These cycles are driven by the nuclear fusion occurring in their cores, where hydrogen atoms fuse to create helium, releasing vast amounts of energy. But a star's journey is dictated by its mass, and how it lives and dies depends largely on its size. The stellar nursery, the birth of stars. The birth of a star begins in a stellar nursery, a vast cloud of gas and dust floating in space. These molecular clouds, primarily made of hydrogen, are cold and dense. Over time, gravity causes the gas and dust to collapse inward, increasing pressure and temperature until nuclear fusion begins in the core. This marks the birth of a new star. As the newly formed star continues to burn hydrogen into helium, it reaches a stable equilibrium where the inward pull of gravity is balanced by the outward pressure of the fusion reactions. This stable phase, known as the main sequence, is where stars like our sun spend the majority of their lives. During this time, stars radiate light and heat, providing energy for planets like Earth and making life possible. The death of stars, red giants and supernovae. But stars do not live forever. Eventually, their hydrogen fuel runs out, and the star begins to expand and evolve. Stars with mass similar to our sun will become red giants, swelling in size as they burn heavier elements in their cores. The outer layers of the star will expand outward, and eventually, the star will shed these layers, forming a planetary nebula. What remains is the white dwarf, a dense, hot core that slowly cools and fades over billions of years. However, for more massive stars, the end of their life is much more dramatic. These stars will go through a series of stages where they burn heavier elements, eventually leading to the creation of iron in their cores. Once the core is made of iron, fusion stops, and the star can no longer support itself against the pull of gravity. The result is a supernova, a catastrophic explosion that can outshine an entire galaxy. During a supernova, the star's outer layers are blown off, scattering the elements it has created into the cosmos. These elements, including carbon, oxygen, and iron, are the building blocks of planets and life. The supernova explosion also creates neutron stars, or, in the case of the most massive stars, black holes, marking the final stages of the star's existence. The search for extraterrestrial life. As we continue to explore the cosmos, one of the most profound questions we seek to answer is, are we alone? The search for extraterrestrial life has captivated humanity for centuries, with billions of stars in the Milky Way alone, and even more galaxies beyond. The possibility of life on other planets seems almost inevitable. The discovery of exoplanets, planets orbiting stars outside of our solar system, has opened up new possibilities for the search for life. Thousands of exoplanets have been discovered, many of which lie in the habitable zone of their stars, where conditions may be right for liquid water to exist. These planets are prime candidates in the search for extraterrestrial life, and missions like the James Webb Space Telescope will allow us to study their atmospheres and look for signs of life, such as oxygen, methane, and other biosignatures. The search for water and life beyond Earth. One of the most promising areas in the search for life beyond Earth is Mars. Mars, with its similarities to Earth, has long been considered a potential home for life. In the past, Mars had liquid water, and scientists are now searching for signs of ancient microbial life in its soil. The Perseverance rover, which landed on Mars in 2021, is studying the planet's surface and collecting samples to be returned to Earth in future missions. Other moons in our solar system, such as Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, also show promise in the search for life. Both moons have subsurface oceans beneath their icy crusts, which could harbor microbial life. The Europa Clipper mission, launching in the next decade, will explore Europa's ocean, helping us learn more about its potential for life. The future of space exploration. As humanity ventures farther into space, the future of exploration is incredibly bright. Programs like NASA's Artemis are set to return humans to the moon by 2024, with plans to establish a permanent lunar base in the coming decades. This will serve as a stepping stone for future missions to Mars and beyond. With private companies like SpaceX and Blue Origin leading the charge, space exploration is entering a new era of innovation. SpaceX's Starship, designed for deep space missions, is poised to revolutionize space travel, making it more affordable and accessible than ever before. These developments will not only allow us to explore the Moon and Mars, but also prepare humanity for life beyond our solar system. As we look toward the future of space exploration, the possibilities are endless. With each new discovery, we come closer to understanding the universe and our place within it. The journey of exploration is far from over, and the stars are waiting. Space exploration, pushing the boundaries of human endeavor. Space has always been a frontier, a challenge that humans have sought to conquer. From the earliest observations of the stars to the moon landing in 1969, humanity's thirst for discovery and exploration has led us to push beyond our limits. Space exploration is not just about understanding the cosmos, it's about understanding ourselves, our place in the universe, and what is possible for the future of our species. The space race, a historic milestone. The Cold War rivalry between the United States and the Soviet Union fueled a race to space, marking a defining moment in human history. The 1,950 seconds and 60 seconds saw unprecedented advancements in rocketry and space technology, culminating in one of the most iconic moments of the 20th century, the first human landing on the moon. On the 20th of July, 1969, Neil Armstrong became the first person to set foot on the lunar surface, declaring the famous words, "That's one small step for man, one giant leap for mankind." The Apollo 11 mission marked not just a victory in the space race, but the beginning of humanity's journey beyond Earth. With the moon as our first destination, we learned that space travel was no longer just a dream, it was a reality. The Apollo missions demonstrated the incredible potential of human ingenuity. Despite the immense technical challenges, astronauts journeyed to the moon and returned, bringing back lunar samples that would provide valuable insights into the history of the solar system. These missions set the foundation for modern space exploration, showing that with enough determination and innovation, humanity could reach the stars. Space stations and satellites. Eyes in the sky. Following the Apollo missions, attention shifted to the development of space stations and the use of satellites. The International Space Station, ISS, which orbits Earth at an average altitude of 250 miles, is a testament to international cooperation in space exploration. It serves as both a laboratory for scientific research and a platform for technological development, offering valuable insights into how the human body adapts to the conditions of space. Since its launch in 1998, the ISS has become an essential part of human space exploration. Scientists from around the world work aboard the station, conducting experiments that range from studying the effects of microgravity on human health to understanding the behavior of materials in space. The research conducted aboard the ISS has implications for everything from improving life on Earth to preparing for long-term missions to Mars and beyond. Private space companies, a new frontier. In recent years, private space companies have begun to take on roles traditionally held by government agencies. Companies like SpaceX, Blue Origin, and Virgin Galactic are transforming the space industry, making space travel more affordable, more accessible, and even opening up the possibility of space tourism. SpaceX's Falcon 9 rocket and Starship spacecraft represent a new era of reusable rocket technology. The ability to reuse rockets means that the cost of launching payloads into space is significantly reduced, making it possible for more countries, companies, and organizations to engage in space exploration. SpaceX's Crew Dragon capsule, which successfully carried astronauts to the ISS in 2020, marks the first time a privately operated spacecraft has done so, a milestone in the ongoing commercialization of space travel. Blue Origin, founded by Amazon's Jeff Bezos, is focused on developing technologies for human spaceflight, including its New Shepard rocket, designed for suborbital flights. Virgin Galactic, on the other hand, is targeting space tourism, with its VSS Unity spacecraft providing suborbital flights for private paying customers. The involvement of private companies in space exploration signals a shift in the dynamics of the industry. It opens up opportunities for innovation, competition, and collaboration, making space a more accessible frontier than ever before. The Moon, our first step into deep space. As we look toward the future of space exploration, the Moon will play a crucial role. After decades of focusing on Mars and beyond, NASA's Artemis program aims to return humans to the Moon. But this time, the goal isn't just to visit, it's to establish a sustainable presence. The Artemis program plans to land the first woman and the next man on the Moon by 2024, with the goal of creating a long-term presence on the lunar surface. This mission will build on the lessons learned from the Apollo missions, but with a new focus on establishing infrastructure that can support humans for extended periods. NASA's long-term vision includes building a lunar base that can serve as a platform for future missions to Mars and beyond. The Moon is seen as a stepping stone for future space exploration. Its proximity to Earth makes it an ideal testing ground for technologies and systems that will be needed for deeper space missions. The Moon's resources, including water ice at the lunar poles, may also prove to be valuable in supporting long-term human presence in space. Water is essential for life, and it can be split into hydrogen and oxygen to produce rocket fuel, which could help make space exploration more sustainable. Mars, the next frontier. While the Moon will be our first step, the ultimate goal for human space exploration is Mars. The red planet has fascinated humanity for centuries, with its similarities to Earth making it the most promising candidate for human colonization. Mars has a day length similar to ours, seasons, and evidence of ancient rivers and lakes, suggesting that it may have once supported life. Mars has long been the target of robotic exploration. NASA's Perseverance rover, which landed on Mars in February 2021, is tasked with searching for signs of ancient microbial life and collecting samples for future return to Earth. Perseverance is also testing technologies that could be used in human exploration, such as MOXIE, a device designed to convert Mars's carbon dioxide-rich atmosphere into oxygen. In the coming decades, NASA, along with private companies like SpaceX, is working on developing the technology necessary to send humans to Mars. SpaceX's Starship is designed to carry large crews and cargo to Mars, with the long-term goal of establishing a self-sustaining colony. These missions will present numerous challenges, from protecting astronauts from radiation to providing food, water, and oxygen for extended stays on the Martian surface. Mars holds the potential for humanity's first interplanetary colony, and while there are many obstacles to overcome, the drive to explore and settle on Mars is one of the most exciting goals in the history of space exploration. Beyond Mars, the search for habitable worlds. Mars may be our next destination, but it is by no means our final frontier. As we venture farther into space, the search for exoplanets, planets outside our solar system, has become one of the most exciting fields of study. Thousands of exoplanets have been discovered, many of which lie within their star's habitable zone. the region where conditions may be right for liquid water to exist. The discovery of exoplanets has opened up the possibility that life may exist elsewhere in the universe. Telescopes like the James Webb Space Telescope and Kepler Space Telescope are designed to study exoplanets in unprecedented detail, looking for signs of habitability or even life. The next frontier in space exploration is the search for extraterrestrial intelligence, ETI. While we have not yet found direct evidence of intelligent life, the discovery of thousands of exoplanets, some of which may have similar conditions to Earth, suggests that life elsewhere is a distinct possibility. The search for extraterrestrial life, whether microbial or intelligent, will continue to shape our exploration of the cosmos for generations to come. Looking toward the future, the boundless possibilities of space. The future of space exploration is a canvas still waiting to be painted. With advances in technology and a growing global collaboration in space research, humanity is poised to embark on an exciting new chapter of discovery. Whether it's the establishment of a permanent lunar base, the colonization of Mars, or the search for alien life, the next few decades promise to reveal more about the universe than we could ever have imagined. As we continue to push the boundaries of what is possible, the question remains, what lies beyond the stars? What secrets does the universe hold, and how will we unlock them? The journey is just beginning. The Great Unknown, exploring the mysteries of dark matter and dark energy. The universe is an incredible place, full of awe-inspiring phenomena, but not all of it is visible to the naked eye. For decades, scientists have wrestled with the idea of dark matter and dark energy, two invisible forces that shape the universe in profound ways. Despite accounting for nearly 95% of the total mass and energy in the universe, these mysterious components remain largely unseen and poorly understood. What is dark matter? Dark matter is one of the most perplexing concepts in modern astrophysics. It is an invisible substance that doesn't emit, absorb, or reflect light, making it undetectable by traditional telescopes. Despite its elusiveness, scientists are confident in its existence because of its gravitational effects on visible matter. Galaxies, for example, rotate much faster than they should, based on the visible matter alone. The extra mass required to explain this faster rotation is attributed to dark matter. Dark matter is thought to make up about 27% of the universe's total mass. It does not interact with light or electromagnetic radiation, which is why it remains invisible to our current detection methods. However, its gravitational pull affects the movement of galaxies and galaxy clusters, suggesting that dark matter is scattered throughout the universe in vast amounts. Some of the leading theories about dark matter suggest it is composed of weakly interacting massive particles, WIMPs, but scientists have not yet been able to detect these particles directly. The search for dark matter is ongoing, with experiments taking place deep underground and in space. The Large Hadron Collider, LHC, and other particle accelerators are searching for these elusive particles, while space-based observatories look for signs of dark matter's presence in the cosmic background radiation and the movement of galaxies. Dark energy. The mystery behind the universe's accelerating expansion. While dark matter is an invisible substance that exerts a gravitational pull, dark energy is a force that drives the universe apart. In 1998, astronomers made a groundbreaking discovery. The universe is not only expanding, but its expansion is actually accelerating. This was a surprising revelation, as gravity, what holds galaxies together, should have been slowing the expansion of the universe over time. But instead, a mysterious force, now called dark energy, is pushing galaxies farther apart at an increasing rate. Dark energy is thought to make up about 68% of the universe's total energy, yet little is known about its properties. Unlike dark matter, which interacts with gravity, dark energy seems to have no interaction with other forces in the universe. It is theorized that dark energy is a property of space itself, an energy intrinsic to the fabric of the universe, causing it to expand faster over time. The nature of dark energy is one of the greatest unsolved mysteries in cosmology. If dark energy continues to dominate the universe's expansion, it could lead to a future where galaxies drift further and further apart, ultimately resulting in the Big Freeze, a cold, dark universe with little to no activity. Alternatively, some models suggest that dark energy could change over time, potentially causing the universe to contract in a big crunch or even tear apart in a big rip. The mystical power of nebulae, stellar nurseries of the universe. Nebulae are some of the most beautiful and fascinating objects in space. These vast clouds of gas and dust are the birthplaces of stars, where new stars are born from the remnants of older, dying stars. Nebulae can be incredibly diverse, with some glowing brightly due to the radiation from young, hot stars, while others are dark and dense, hiding their secrets from view. Emission nebulae. The cosmic fireworks emission nebulae are clouds of gas that glow brightly due to the intense radiation from nearby hot young stars. The most famous example of an emission nebula is the Orion Nebula, located about 1,500 light-years from Earth. In this nebula, new stars are born in a stunning display of cosmic energy. The radiation from these newborn stars ionizes the surrounding hydrogen gas, causing it to emit light in a dazzling array of colors, from pinks to greens to blues. These nebulae are the cosmic equivalents of stellar birthrooms, where new stars form from the dust and gas of the nebula. Over time, as the stars continue to shine, the nebula dissipates, leaving behind young stars and planetary systems. Dark nebulae, the hidden wonders of the cosmos. In contrast to emission nebulae, dark nebulae are clouds of gas and dust that block the light from stars behind them. These nebulae are often seen as dark patches against the backdrop of brighter stars and nebulae. While dark nebulae are difficult to observe directly, they are crucial to the star formation process. They are the birthplaces of new stars and planetary systems, but they hide their activity in shadow, waiting for new stars to emerge. One of the most famous dark nebulae is the Horsehead Nebula, located in the constellation Orion. Its iconic shape resembles a horse's head, formed by the dense dust and gas in the nebula blocking the light from behind. Dark nebulae, though hidden from view, are essential to understanding the formation of stars and the evolution of galaxies. The expanding universe. How far will it go? One of the most mind-boggling discoveries of modern cosmology is the realization that the universe is expanding. This discovery, made by Edwin Hubble in the 1920 seconds, showed that galaxies are moving away from us in all directions, with the farther galaxies receding at faster speeds. This observation was confirmed by the discovery of cosmic redshift, where the light from distant galaxies shifts toward the red end of the spectrum as they move away from us. The universe's expansion is driven by the Big Bang, a cataclysmic event that occurred about 13.8 billion years ago, marking the beginning of space and time. Following the Big Bang, the universe expanded rapidly in a process known as cosmic inflation, smoothing out the cosmos and setting the stage for the formation of galaxies, stars, and planets. Over time, the expansion of the universe has slowed, but it has never stopped. Today, the universe is expanding at an accelerated rate, driven by the mysterious force of dark energy. This acceleration could continue indefinitely, leading to a future where galaxies drift farther and farther apart. The future of space exploration, going beyond the known. As humanity stands on the brink of new space exploration technologies, the future holds unprecedented opportunities for discovery. Missions to Mars, the Moon, and beyond are already in development, and private companies like SpaceX are working toward making space travel more accessible than ever before. As our understanding of the universe continues to grow, we will unlock new mysteries and expand our reach further than we ever thought possible. Manned missions to Mars. The dream of sending humans to Mars is closer than ever before. NASA's Artemis program, while focused on returning to the Moon, also lays the groundwork for future manned missions to the Red Planet. The Moon Gateway, an outpost planned to orbit the Moon, will serve as a stepping stone for astronauts on their way to Mars, providing the necessary infrastructure for long-term space travel. Private companies like SpaceX, led by Elon Musk, are working on Starship, a massive spacecraft designed for interplanetary travel. The goal of SpaceX is to send humans to Mars by the mid-2020s, with the long-term vision of creating a self-sustaining colony on the planet. The challenges of sending humans to Mars are immense, from the dangers of space radiation to providing food, water, and oxygen, but the excitement surrounding this goal is palpable. The search for life beyond Earth. The search for extraterrestrial life is one of the most profound questions humanity has ever asked. With the discovery of thousands of exoplanets, many of which are in the habitable zone of their stars, the possibility of life beyond Earth is more real than ever. In the coming decades, space missions will focus on exploring these exoplanets for signs of life, whether microbial or intelligent. The James Webb Space Telescope, slated for launch soon, will be able to study the atmospheres of exoplanets in unprecedented detail, looking for signs of life-sustaining conditions. The next few decades could bring us closer to answering the age-old question: are we alone? The infinite journey. The universe is a place of wonder, mystery, and endless discovery. As we continue to explore the cosmos, we will uncover secrets about the stars, the planets, and ourselves. The journey is just beginning, and with each new discovery, we expand our understanding of the universe and our place within it. From the birth of stars to the search for life beyond Earth, from the vastness of galaxies to the mysteries of dark matter, the cosmos holds an infinite number of stories waiting to be discovered. The stars are not just distant lights in the sky, they are the beacons of our future. The universe is waiting, and we are just beginning to scratch the surface of its deepest mysteries. The role of artificial intelligence in space exploration. As we venture farther into the universe, the complexities of space exploration become even more apparent. From navigating the vast distances between planets to analyzing data collected from distant stars, space exploration demands tools that go beyond human capabilities. This is where artificial intelligence (AI) comes into play. AI in spacecraft navigation and autonomous operations. The sheer distances and harsh conditions of space make it impossible for humans to be present at all times. AI allows spacecraft to operate autonomously, adjusting their course, performing scientific experiments, and even troubleshooting issues without the need for human intervention. One of the most notable examples of AI in space is the Mars rovers, particularly Curiosity and Perseverance. These rovers are equipped with AI algorithms that allow them to analyze their surroundings, make decisions, and navigate the Martian terrain with minimal human input. The ability of these rovers to perform tasks like avoiding obstacles, selecting the best route, and analyzing soil samples in real time is a direct result of advancements in AI technology. As we prepare for future missions to Mars, AI will play an even larger role in ensuring the success of these missions. Spacecraft like SpaceX's Starship and NASA's Orion will rely heavily on AI to manage operations during long-duration missions, as well as to ensure astronauts' safety and well-being in the challenging environment of space. AI for data analysis. Unlocking the secrets of the cosmos, AI's role in space exploration goes beyond autonomous operations. It is also crucial for processing the vast amounts of data generated by space missions. Space telescopes like Hubble and James Webb, as well as interplanetary missions like New Horizons and Juno, collect terabytes of data about distant stars, planets, and galaxies. Human scientists are limited in their ability to sift through this immense amount of information. This is where AI excels. Machine learning algorithms can be trained to analyze data, recognize patterns, and identify significant features that would otherwise go unnoticed. For example, AI has been used to detect exoplanets by analyzing the slight dimming of stars as planets pass in front of them, a process that would take humans years to do manually. AI can also help detect anomalies in cosmic radiation, enabling scientists to identify phenomena like supernovae, gamma-ray bursts, and even the presence of dark matter. The ability to analyze and interpret this data in real time is revolutionizing our understanding of the universe. AI is not just assisting space missions, it is making discoveries that were previously impossible for humans to make on their own. The expanding frontier of space colonization. As we turn our eyes to the future, one of the most exciting possibilities is the idea of space colonization. While this idea may seem like something out of science fiction, it is fast becoming a realistic goal for the coming decades. With the advent of new technologies, the prospect of humans living on other planets is no longer a distant dream. It is an inevitable part of our future. The Moon, a stepping stone for humanity. The Moon, Earth's closest celestial neighbor, is the perfect starting point for humanity's expansion into space. Unlike other planets in our solar system, the Moon is within reach of our current technology, making it an ideal location for establishing a permanent human presence. NASA's Artemis program, which plans to return astronauts to the Moon in the coming years, is focused on establishing a sustainable base on the lunar surface. This base will serve as a launch point for further exploration, including future missions to Mars. In addition to being a base for space exploration, the Moon may also hold valuable resources. Water ice has been discovered at the lunar poles, which could be used to produce oxygen and hydrogen for life support and rocket fuel. By tapping into the Moon's resources, humanity can build a sustainable presence on the Moon without relying solely on Earth for supplies. The Moon may not be the ultimate destination for space colonization, but it is a crucial first step. As we develop the necessary infrastructure to live and work on the Moon, we will gain the experience needed to tackle the more significant challenges of space colonization, such as living on Mars. Mars, the next frontier for human settlement. While the Moon offers a foundation for exploration, Mars is where the true dream of space colonization lies. Mars is similar to Earth in many ways. It has a day length close to ours, a gravity field that is about 38% of Earth's, and a surface area that is roughly the same size as all of Earth's land masses combined. For these reasons, scientists have long considered Mars to be the most suitable planet for human settlement. The challenges of living on Mars are considerable, however. The planet has a thin atmosphere composed primarily of carbon dioxide, and temperatures can drop to negative 195 degrees Fahrenheit at the poles. Mars also lacks a global magnetic field, which means that its surface is exposed to harmful cosmic radiation. Yet, despite these obstacles, Mars is still the best candidate for the first human colony beyond Earth. NASA's long-term goal is to send astronauts to Mars by the 2032, with missions focused on studying the planet's surface, its climate, and its potential for sustaining human life. SpaceX, with its Starship project, aims to establish a self-sustaining colony on Mars, with the vision of making life multi-planetary. The process of setting up a colony will be gradual, first sending robotic missions to scout and build infrastructure, followed by human missions to establish a permanent base. Living on Mars will require innovations in life support systems, including the production of food, water, and oxygen. The Mars Society and other space organizations are researching methods for terraforming Mars, or altering its environment to make it more hospitable for human life. These efforts include finding ways to create a breathable atmosphere, warm the planet, and generate sustainable sources of energy. While we are still in the early stages of colonization, Mars represents the next step in humanity's journey into space. A colony on Mars could serve as a backup for civilization, ensuring the survival of humanity in the event of a catastrophe on Earth. It could also serve as a hub for exploring the rest of the solar system, including asteroids, moons, and other planets. Beyond Mars, the search for new frontiers. While Mars is our next frontier, it is not the final destination. As technology continues to evolve, space agencies and private companies are already looking beyond Mars to the distant stars. The search for habitable exoplanets is one of the most exciting areas of modern astronomy. The search for Earth-like exoplanets. With the discovery of thousands of exoplanets orbiting distant stars, scientists are now focused on finding planets that are similar to Earth. These planets, located in the habitable zone of their stars, have the potential to support liquid water, one of the key ingredients for life as we know it. Telescopes like the Kepler Space Telescope and the James Webb Space Telescope have already identified several exoplanets that might be capable of supporting life. Some of these planets are located just a few light-years from Earth, within reach of future space missions. The discovery of an Earth-like planet in the habitable zone of its star would be one of the most significant discoveries in the history of space exploration. Future missions will continue to look for exoplanets with conditions similar to Earth, where life could potentially thrive. If we find such planets, the next challenge will be determining if they are truly habitable and whether they harbor life. If so, the discovery of extraterrestrial life would fundamentally change our understanding of the universe and our place within it. The infinite possibilities of space. As we conclude this journey through the cosmos, it becomes clear that the possibilities are limitless. The universe is vast, and we have only just begun to explore its many wonders. Whether it's the study of black holes, the search for life on Mars, or the quest for habitable exoplanets, space holds endless opportunities for discovery. The challenges of space exploration are immense, but humanity's curiosity, ingenuity, and determination will continue to drive us forward. From the first step on the Moon to the first human colony on Mars, the future of space exploration is filled with exciting possibilities. The universe is waiting, and the next chapter of human history is yet to be written. The journey has only just begun. The universe, with all its mysteries and beauty, is not just an object of our curiosity, it is our ultimate destination. The stars, planets, and galaxies that have captivated our imaginations for millennia are now within our reach. As we continue our journey into the cosmos, we will uncover secrets that will challenge our understanding of science, philosophy, and even our place in the universe. But the journey is just beginning. As we look to the future, humanity will explore not just the stars, but the very fabric of space and time itself. The infinite expanse of the universe holds untold wonders, and with each discovery, we take one step closer to understanding the vastness of existence. So, what's next? We've barely scratched the surface of what space has to offer, and the journey ahead will reveal more than we could ever imagine. The stars are waiting, the adventure is just beginning. Space technology, the tools that drive exploration. Humanity's journey into the stars wouldn't be possible without the extraordinary advances in space technology. Over the past few decades, technological innovations have transformed how we explore space, enabling us to send probes to the far reaches of the solar system, land rovers on other planets, and even launch missions to explore asteroids and comets. But what makes this progress possible? Rocketry, the power behind space travel. At the heart of space exploration lies rocketry, the science of building spacecraft capable of escaping Earth's gravity and traveling through the vastness of space. From the first rockets of the 20th century to the powerful spacecraft of today, rocket technology has evolved rapidly, driven by advancements in materials science, propulsion, and engineering. The development of reusable rockets is one of the most significant breakthroughs in modern space technology. SpaceX's Falcon 9, for example, is capable of landing back on Earth after launching its payload into space. This reusability reduces the cost of space travel and opens the door for more frequent missions. The Starship project, currently under development by SpaceX, aims to make human space travel more affordable and sustainable, with the potential to send humans to Mars and beyond. Propulsion systems, how we reach farther than ever before. While traditional rocket engines rely on chemical propulsion to launch spacecraft into space, electric propulsion is another exciting development. Electric propulsion systems, like ion thrusters, use electric fields to accelerate charged particles to incredibly high speeds, making them ideal for long-duration space missions. While ion thrusters produce much less thrust than chemical rockets, they are highly efficient, allowing spacecraft to travel long distances with minimal fuel. This technology is already being used in missions to explore the outer planets and asteroids. The development of nuclear propulsion is another area of research that could revolutionize space exploration. By using nuclear reactions to generate energy, spacecraft could travel much faster and farther than with chemical or electric propulsion alone. This technology is still in the early stages, but it holds the potential to dramatically reduce travel times to distant planets, like Mars, and open up new possibilities for interstellar exploration. Astrobiology, searching for life beyond Earth. As we venture farther into space, the search for extraterrestrial life becomes a key focus. With the discovery of exoplanets and the study of Mars, the quest to find life beyond Earth has moved from the realm of science fiction to a pressing scientific goal. What if we are not alone in the universe? Are there other forms of life out there, perhaps thriving on distant worlds? Astrobiology is the branch of science dedicated to studying the potential for life elsewhere in the universe. Researchers in this field look for planets with conditions that might support life, focusing on planets within the habitable zone of their stars, the region where temperatures are just right for liquid water to exist. Water is considered essential for life as we know it, and finding a planet with liquid water is one of the first steps in determining whether life might exist there. The search for extraterrestrial intelligence, SETI. The search for extraterrestrial intelligence, SETI, has been ongoing for decades, driven by the question, are we alone in the universe? SETI scientists use powerful radio telescopes to listen for signals from other civilizations. The hope is that, somewhere in the cosmos, an advanced civilization might be transmitting signals, either intentionally or unintentionally, that we can detect. While no definitive signals have been found yet, the search continues. The recent discovery of thousands of exoplanets, many of which are in the habitable zone of their stars, has increased optimism in the scientific community. As we refine our search methods and develop new technologies to study distant planets, the possibility of discovering extraterrestrial life grows ever closer. The mysteries of cosmic radiation and space weather. The universe is filled with cosmic radiation, high-energy particles traveling through space at nearly the speed of light. This radiation, originating from the sun and other cosmic sources, can have significant effects on both spacecraft and astronauts. Space weather, driven by solar activity such as solar flares and coronal mass ejections, can disrupt communications, damage satellites, and pose a risk to human health during deep space missions. Solar winds and space weather. The solar wind, a continuous stream of charged particles emitted by the sun, carries with it a variety of high-energy particles. These particles interact with Earth's magnetic field, creating phenomena like the aurora borealis. However, solar winds can also disrupt the operations of spacecraft, causing malfunctions in electronics and communications. Solar flares, which are sudden bursts of energy from the sun, can release intense bursts of radiation that can pose serious risks to astronauts. As humanity looks toward deep space exploration, understanding space weather and its effects on spacecraft and humans is crucial. Research into the sun's behavior and the nature of cosmic radiation will help engineers design better protection for spacecraft and create technologies to mitigate the effects of space weather on both astronauts and satellites. Interstellar travel, beyond our solar system. While missions to the Moon, Mars, and beyond are already underway, the idea of traveling to other star systems, known as interstellar travel, remains a distant dream. The vast distances between stars present an enormous challenge for human space exploration. The closest star to Earth, Proxima Centauri, is over 4 light-years away, a distance that current spacecraft would take tens of thousands of years to reach. Warp drive and faster-than-light travel. The concept of faster-than-light, FTL, travel has been a staple of science fiction for decades, but it has also captured the imagination of theoretical physicists. One of the most famous concepts of FTL travel is the warp drive, a hypothetical propulsion system that would allow a spacecraft to travel faster than the speed of light by bending or warping space itself. While the idea is based on Einstein's theory of general relativity, a warp drive would require vast amounts of energy far beyond what is currently possible. Another potential method of interstellar travel is wormholes, theoretical passages through space-time that could create shortcuts between distant points in the universe. However, wormholes remain purely hypothetical, and no evidence has yet been found to suggest that they exist or could be stabilized for use in space travel. Breakthrough propulsion technologies. While interstellar travel remains far from reality, several innovative propulsion technologies are being explored to make long-distance space travel more feasible. Project Longshot, a proposed mission to Proxima Centauri, aims to send a probe to the star using a nuclear fusion rocket, a technology that could potentially accelerate a spacecraft to 10% of the speed of light. Breakthrough Starshot, a more recent initiative, proposes using light sails powered by lasers to accelerate small probes to a fraction of the speed of light, potentially reaching Proxima Centauri in just over 20 years. The future of space colonization. As we look ahead, the dream of colonizing other planets and even other star systems is not as far-fetched as it once seemed. The final frontier, what lies beyond? As we reach the edge of our current understanding, we look to the unknown. The final frontier is not just about traveling to distant stars or landing on new planets, it is about discovering what lies beyond our perceptions of reality. With each passing day, we are pushing the boundaries of what we once thought was impossible. The multiverse, a universe of infinite possibilities. One of the most mind-expanding theories about the universe is the idea of the multiverse, the concept that our universe is not the only one. According to this theory, there could be an infinite number of parallel universes, each with its own set of physical laws, dimensions, and realities. These universes might exist alongside our own, and the possibilities for life, matter, and energy in these parallel worlds could be beyond imagination. While the multiverse remains a speculative concept with no direct evidence to support it, it opens up a world of possibilities. What would life look like in another universe? Could there be other versions of Earth where life took different paths? The idea that there are infinite versions of reality could be one of the most profound revelations about the nature of existence. The power of human imagination. Creating the future space exploration is not just about rockets, telescopes, and artificial intelligence. It is about human imagination. For millennia, our ancestors looked up at the stars and dreamed of reaching them. From the earliest myths to the first spaceflight, humanity's imagination has driven the quest to explore the cosmos. The future of space exploration will rely on this same creative spirit. It is our ability to dream big, to think beyond the limits of our current technology, that will define the next chapters in the story of space exploration. Whether it's building cities on Mars, unlocking the secrets of black holes, or discovering life on other worlds, it will be the power of human imagination that drives us to the next great leap forward. With advancements in technology and new breakthroughs on the horizon, the possibilities for what we can achieve in space are boundless. New generations of scientists, engineers, and dreamers will continue to push the limits of what is possible, ensuring that humanity's journey through space will never end. The legacy of exploration, how space changes us. As we venture farther into space, we must not forget the profound impact that space exploration has on us as individuals and as a species. The lessons we learn from exploring the cosmos extend far beyond the stars. They shape our worldview, inspire us to think about our place in the universe, and challenge us to reconsider the boundaries of what we can achieve. Perspective from space, the overview effect. One of the most transformative experiences for astronauts is the overview effect, the sensation of seeing Earth from space. When astronauts look at our planet from orbit, they often describe a sense of awe, unity, and responsibility. Earth appears small, fragile, and interconnected, floating in the vastness of space. The overview effect challenges our perceptions of national borders, conflicts, and differences, reminding us of our shared humanity and our responsibility to protect our planet. This perspective has led to a greater focus on global cooperation, environmental sustainability, and the preservation of Earth's natural resources. As we look to the stars, we must also look inward, ensuring that our actions on Earth align with the lessons we learn in space. Space and the future of humanity. The journey to explore the cosmos is more than just a scientific endeavor. It is a moral and philosophical journey. As humanity ventures into space, we must consider the future of our species. How will we coexist with the environment of other planets? What are the ethical implications of space colonization? Can we learn from our past mistakes on Earth and create a future in space that is harmonious, sustainable, and just? Space offers us an opportunity to rethink the way we live on Earth and to build a future that reflects the best of humanity. By pushing the boundaries of our knowledge and technology, we can ensure that the legacy of space exploration is one of progress, unity, and hope for future generations. A new dawn, the next chapter in space exploration. As we conclude our journey through the cosmos, it's clear that the future of space exploration is bright. The vastness of the universe is both humbling and exhilarating, and each new discovery opens up new possibilities for understanding our place in the cosmos. We stand on the edge of a new era, one in which humanity will reach farther than ever before. From the moon to Mars and beyond, space exploration will continue to captivate our imaginations and push the limits of what is possible. The next chapter of space exploration is about more than just exploring new worlds. It's about answering the deepest questions of our existence, pushing the boundaries of human capability, and inspiring future generations to look up at the stars and dream of the impossible. The stars await. In the end, space is not just about the technology we develop or the missions we complete, it's about the journey itself. It's about the curiosity, the passion, and the relentless drive that pushes us to explore, to discover, and to grow. The universe is vast and full of mysteries, and as we continue to explore its wonders, we realize that the adventure is only just beginning. The stars are waiting, and the future of space exploration is one of limitless potential. The universe calls to us, the stars beckon, and we, as a species, will answer the call.